Hey everyone, Nitesh this side. Hope you're doing well. So let's start with the question. So the question is rotate list. Okay. So you have given the head of the linked list and you have to rotate the list to the right by k places. Okay. So there is a twist in rotating. You have to rotate the linked list in a right direction, but only to the k places. Okay. So let's see with this with an example. Okay. So let's take this example. So we have this 1, 2, 3, 4, 5, and it's pointing to null. This is your head. Okay. You have to rotate by two places. Okay. So let's say you rotate for 1. So after this will become like this 5 will come at here and all element will be shifted. So it will be become 5, 1, 2, 4 and a null. And this is your head. But you have to do 2 times. So you will do R2 equal to. So this 4 will come here. So this will become 4, 5, 1, 2 and a null. So this is your final output. Okay. So let's see how we can approach this question. Okay, so let's take the same example and what like if I go with the naive approach, what I will do, like I will start from here. Okay. Every time I will find out the last element. So this is my last element. And what I will do, I will break this pointer and take this element to its start. Okay. So for our case, k equal to 2, so this will become 5, 1, 2, 3, 4, and a null. Okay, so this is your head. I will do again the same work. What I will do, I will go to the last, like I will find out tail element. So I will take this element, I will break this pointer, and I will take it at here. So this will become 4, 5, 1, 2, 3. Okay. So if you calculate the time complexity for this is basically what I'm doing, I will start from here and every time I'm going to the last of the linked list. So for this, my time complexity will be order of n, and how many times I have to do? So I have to do for k times. Okay. So this will be order of n into k. Okay. So let's see how we can optimize it or more further. Okay, so before optimizing in the question, like in the constraint, it's also mentioned like k can be greater or equal to len. Okay, so first of all, like first solve the problem. Like if k is less than equal to len, it like less than n. So this we can easily do. Like we just have to rotate for k times, but let's see if k is greater or equal to len. Okay, so let's take an example for k equal to 4. So what we will do for k equal to 1, it will become 3, 1, 2 and a null. Okay, for k equal to 2, it will become your 2 will come here, 2, 3, 1 and a null. Okay, for k equal to 3. Okay, so it will become 1, 2 null, and for k equal to 4, it will become uh basically 3, 1, 2 null. Let's calculate till 6 also. Okay, 5 will become 2, 3, 1 null, and for k equal to 6, it will be 1, 2, 3. Okay. So if you calculate the length of this linked list, it's 3. Okay. So what you can see in the observation, like at every 3 multiple, you getting the same position. Because it's pretty clear, like if you rotate the linked list with the same length at twice, like at the same length, it will come to the same position. So if you can see at 3 we are getting the same position, at 6 we are getting the same position. So let's say if you given the condition to rotate for k equal to 3 or k equal to 18, so why we are doing for 18? We can just do this for only k equal to 3. Why we have to do for 18 times? Okay, so what we can see is, and you can also see for k equal to 4, we getting this 3, 1, 2. For k equal to 4, we are getting also 3 and 1, 2. So we can optimize our k. So we can reduce k by like this. K will always be len minus k modulo. It should. So by this way, we can easily reduce our k by k less than n. If it is greater or equal to, so if your k is greater or equal to len, we can easily convert this to. Okay. Okay. So if you calculate for k equal to 1, so k equal to 1 mod 3, it will give you 1. If you calculate for 4, so it will be mod 3, it will give you 1. Okay. And if it is a k multiple, so let's take 18 mod 3 equal to, it will give you 0. So you don't have to rotate. Okay. So we have optimized our k. So now let's see how we can approach this question. Okay. So let's optimize our previous approach. So for this input, we are getting this output. Okay. So our first step is basically what we will do. We will first calculate length. Okay. So what we will do, you will start, you know how to calculate the length of the linked list. You will start from here. Every time you will go further, you will come at here, 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 and you can easily find the length of this element. So length is equal to 5. Okay. Now the second step, what you need to do, you need to remove like it, your null will like last element, your tail element is pointing to null. You have to point this element to this. Basically, it will point to here. Okay. So if you can see the output, okay. So like your output will be 4, 5. I miss one. Okay. So if you can see the output, it will be like 4, 5. Then your next will be pointing to 1 and 2, 3. So 1, 2, 3. What we need is basically remove this pointer. How we can remove this? Okay. So if you know your k equal to 2, okay, and you know your length, so what we can do, we can calculate the length of this part. Basically, how we can calculate, so we can easily calculate your length minus k. Okay, so if you do, so it will become length is 5 and this is k, so k is 2, so this will become 3. Okay, so what we need to do, we will take one variable from here. So let's take a current variable. We'll go as many as times. So as you can see, is 3 times. So we'll go to here 1, 2, and this 3. Okay. So we reach here. So what our first step is basically, what we will do, current dot next. Now this will be our new head. So head will now not pointing at here. Head will point at here. And you will do current dot next equal to null. Okay. So you just do like your head is equal to current dot next and current dot next equal to null. Okay, so after this you get this output. Okay, so it will be more clear if we write a code. Okay, so our first step is to calculate the length. So what we will do, we'll take a length variable which will start from 1. Okay, so we'll do like this, while head dot next is not null, calculate length, increment length, and update your head. Or let's take a variable also, because head we need to point at some at starting point. So this will be my temp, and every time I will move my temp, so temp will be temp dot next. Okay, so after this, what I have to do, I have to first update my k. So k will always be k mod length. Okay, so you are always getting the kth value less than length. So this is you 10. After this, what you have to do, you have to calculate the gap, or let's give a gap variable. It will be length minus k. Okay, what you have to do, you have to take one current variable which will start from head, and while your gap is greater than 0, you have to do current equal to current dot next, and you really have to reduce your gap. Okay, after this you have to just do your head will point to current dot next, and your current dot next is equal to null. Okay, and after that you just return the head. Okay, let's run the code. Okay, so let's run it. Oh, there, like, we miss one condition. Your temp dot next will point to head. Basically, from the last node, you have to point it to the starting linked list node. Okay, and like this will be your zeroth index. Let's remove this. Okay, let's run the code. So as you can see, our code is accepted. Let's submit it. Okay, so we have missed one condition. If okay, okay, so we forgot to add edge cases. So basically, if your head is equal to null, or let's say your head dot next equal to null, or you can also say your k is equal to 0, so you just return the head from there. Okay, let's see. Let's give the empty linked list, and this will be 0. Let's run the code. So this is accepted. Let's submit it. So as you can see, our code is submitted. Okay, so the time complexity is basically what we are doing. We are calculating the length. So for this, order of n, and we are also doing for some gap. So order of gap. So if you do the overall, so it will be order of n, and the space we are just using order of n. Hope you like it. Thank you for watching my video.